Right, I'm going to rattle through a bunch of dot cross diagrams that you would be potentially asked to draw in paper one or paper one chemistry tomorrow. So it might be that you're asked to draw a dot and cross diagram for a simple covalent molecule. In other words, one that's made of a group of non-metal atoms. So really look out for the fact that it's going to be simple covalent, and you've got non-metals. If you've got a metal and a non-metal, it'll be ionic. So if you're drawing these, first thing to remember is how many bonds each type of atom can make. Hydrogen can make one bond because it's got one electron in its outer shell, and therefore there's space for one more electron because hydrogen has only got the first shell, and therefore it can make one bond. Carbon's in group 4, so there's space for 4 more electrons, so it can make 4 bonds. You should know these numbers. Oxygen's in group 6, which means there's space for 2 more electrons to get a full outer shell. Space for 2 electrons means it can make 2 bonds. Nitrogen's in group 5, it can make 3 bonds. There's space for 3 electrons. Chlorine's in group 7, which means, as is fluorine, which means they've got space for 1 more electron, which means they can make 1 bond. That's your starting point. So know how many bonds things make to start with, or simply work it out from the number of spaces in the outer shell. Then if you're asked to draw a molecule, start always by drawing what we'll just simply call a line diagram. Now, the definition of a covalent bond is a shared pair of electrons between 2 atoms. And so if we're asked to draw H2, start off by drawing an H bonded to another H. Each hydrogen there is making 1 bond, and so the only way to draw it is like that. This line, this bond, represents a covalent bond, which means it represents 2 electrons. So draw those 2 electrons in between 2 hydrogen atoms. Job done, and that's the answer. We always make sure each shell is full. This shell's got 2 in, this shell's got 2 in. Hydrogen being a very small atom, only has 1 shell. That first shell can only hold 2 electrons, and so it's full. Job done, that's it. What about CH4? Carbon can make 4 bonds and hydrogen 1 bond. So the only way to draw that is like so. And so each of those lines represents a pair of electrons. And so there's 1 pair of electrons between each carbon and hydrogen atom. So do that, that gets us a mark. We just check that all of the atoms have got full outer shells, and in this case they do. Hydrogen's got 2, 1, 2, there they are in that outer shell, and that hydrogen's got 2, and the carbon has got 8, 1, 2, 3, 4, 5, 6, 7, 8. All of these atoms, the maximum you can get in the outer shell is 8. So we make sure they've got 8 in our picture. Water. Hydrogen can make 1 bond, oxygen can make 2 bonds. The only way to draw it is like that. Please make sure hydrogen's only making 1 bond. You quite often get people trying to do this. Of course that's not right, because hydrogen there's making, well, it's just wrong for lots of reasons. So we draw each line, it's representing a pair of electrons, we do that, and then we check to make sure the shell is full. The hydrogen shell here is full, the hydrogen here is full. The oxygen is not. We need 8 in the outer shell of oxygen, along with all of these others. So we need 2 more electrons there and 2 more electrons there to make 8. Job done. What about ammonia, NH3? Nitrogen can make 3 bonds. It says up here hydrogen can make 1. Draw the line diagram first. Then draw it with the circles. Do that first. That's not very good, is it? I've got that overlapping. Probably draw that, rub that out and draw that again in an exam. Make sure they're full. That's full. That's full. That's full, because they've all got 2 in the outer shell. But hydrogen, the nitrogen only had 6, so we need 2 more. If in the exam you've ended up making it as scruffy as that one, draw it again nice and neatly. So just a little clue for you, a little tip. Nitrogen will always have 1 lone pair on it, which is something, an expression we use it in 6th form. Extra pair of electrons, lone pair of electrons we call them. Oxygen's always got 2 lone pairs of electrons. A little tip for you. If it's HCl, the halogens, by the way, always have 3 lone pairs of electrons, but stick with the way that I've taught you. Each of those, hydrogen and chlorine, make 1 bond, draw the line diagram, and then check the outer shell is full. Chlorine needs 8 more. When it gets a bit more difficult is when you've got double bonds. If you're asked to draw O2, oxygen makes 2 bonds, so the only way to draw that is like so. And as we said before, a little tip for you, oxygen has always got 2 extra pairs of electrons. Just a little reminder. But we've now got oxygen making 2 bonds, and so it had to be a double bond. And so when you're drawing this as a dot and cross diagram, each line represents 2 electrons. So we're going to have 4 electrons in there. At GCSE, it doesn't matter whether you draw dots and crosses, no one really cares, or where you put the electrons, but just make sure you've got a total of 8 in each outer shell for oxygen. Job done. And again, as always, oxygen's got 2 pairs of electrons. What about nitrogen? Nitrogen makes 3 bonds, so the only way to draw it is like so. That's a triple bond. So there's 6 electrons, 2. Don't know why I've drawn it so badly. But there we are, there's 6 electrons in there. Again, if you're scruffy like me, you need to draw it again, and then make sure that each shell has got 8 electrons in them. So 6 in there, plus 2 more makes 8. And again, as always, nitrogen's always got 1 pair of extra electrons, 1 lone pair. You can draw every possible one like this. One that often catches people out is CF4. CF4 like that. Each carbon makes 4 bonds, each fluorine makes 1 bond, and then you draw it. All halogens always have 3 pairs of electrons extra. Here's your little tip, but just stick with the way that I taught you and you'll be fine. There it is, a pair of electrons there, 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 and there. Carbon's now full, that's good, 1 mark, tick. What about the fluorines? Well, you've got to draw 6 more electrons, or draw those ones as dots for some reason, doesn't really matter, no one cares. But draw 6 more electrons in each of the outer shells of all of the fluorines. Job done. And it could be any combination of these atoms, but just make sure this is the thing you go into the exam. If you can remember that oxygen's always got 2 extra pairs of electrons, nitrogen's always got 1 pair of electrons extra, and chlorine and fluorine have always got 3. That might help you on the way, help double check you've got it right. Remember also that simple covalent substances have low boiling points, and that's because there are weak intermolecular forces between the molecules which require little energy to break. Rehearse that, ask your friend in the morning, practice it with each other, and be ready to say it.